on this episode of A Skin Depth Convo.
That actually is nature's UV absorbing compound. So far, every test that's been done shows that it is safe, it is non-toxic, it is being produced in the world's oceans, it is being produced in the world's soil, it is being produced in the food you eat.
This is a show focused on educating and inspiring all those in the skincare and beauty industry. But it is also a show for those looking to improve themselves from the inside out. In each episode, we explore the latest trends, breakthrough technologies, and get expert insights within the dynamic world of skincare and beauty. If you're looking to further your beauty education and nurture your passion, you're in the right place. Renowned experts and hosts Metaxia and Francine aim to educate and inspire through their own experiences and are dedicated to enlightening and empowering enthusiasts and professionals in the realm of skincare and beauty. Join the conversation and the fun with a Skin Depth Convo. Welcome to Skin Depth Convo. I'm Anna Kagarakis. Somewhere, something incredible is waiting to be known. This was a quote from the late journalist and senior science writer Sharon Begley. Innovation starts with new ideas and discovery. Today, we'll talk to two scientists whose research on the origin and evolution of life and how to build bio-based life support systems in space actually led them to a breakthrough technology that will revolutionize skincare and help our world. We'll be joined in a bit by the founders of HelioBioSys, Dr. Rocco Mancinelli and Dr. David Smernoff. But first, let's welcome in our expert hosts, part of the founders of Lyra Clinical, Metaxia and Francine Kagarakis. I know you both have been really excited about this interview and to find out more about cyanobacteria, but what initially drew you to finding out more about this technology?
Well, we've always been interested in new ingredients and new technology for skincare because innovation is moving so very fast at this time. But what happened is we have a certain representative, her name is Cindy Ma, that works for the U.S. Commerce. And she was working not only with us, but she was also working with HelioBioSys. And they were looking for information about cosmetic technology, cosmetic innovation. And she felt it was very good to pair us together to get some information for them and to let us know what's on the horizon and what's new for SPF and new ingredients and some of the research that they were working with. So we got together, Metax and I met with David and Rocco. They were in the beginning parts of learning more and more about cyanobacteria.
Research takes time. And if you could see 2019 to 2023, to have this opportunity to work with them through the different stages of the development and research, we are very fortunate as Lyra co-founders to be able to understand the time and effort it takes to understand the science behind it. And I think Lyra is just a company that really is looking not just to produce a product, but to produce a lot more science behind what nature naturally gives us.
Yeah, and cyanobacteria, when you first looked it up, was it something that you were just like, I want to learn more? What did you think?
First, we're trying to find the definition of it because we had no idea what it was.
Well, what we found out, it was pond scum. And what importance does pond scum have with cosmetic innovation? So we learned about cyanobacteria and what benefits it offers. This was very unique and very different. And we were looking at new ingredients from a different perspective. We are finding out how all the different benefits that nature has to offer.
Yeah, but there's definitely a process to it. Now, both of them actually met at the NASA Ames Research Center. We'll hear more about how they met in the interview, but just to give the audience a little heads up on their credentials and their background, do you want to share a little bit of about their history?
Sure. Dr. David Smernoff received his master's in environmental management from the University of San Francisco, our hometown, and his doctorate from Stanford. He spent 20 years at NASA Ames Research Center developing and managing research systems to study the interaction between organisms and their environment. That research focused on the integration of biological and engineered systems to support human life on space missions. His experience led him to his current role as a co-founder and inventor of HelioBioSys. That doesn't even cover everything he does.
The other half of the equation is Dr. Rocco Mancinelli. He has his Ph.D. from the University of Colorado, Boulder, with more than 25 years of technology experience in bioproduction and processing. He is a senior research scientist with the Bay Area Environmental Research Institute and a founding member of NASA's synthetic biology program. He published more than 100 peer-reviewed papers in journals. He is the editor-in-chief of the International Journal of Astrobiology. Rocco was awarded a National Academy of Sciences Research Fellowship and the Antarctic Service Medal, but a major part of his focus has been on microbiology, photobiology, and the origin of life, which will lead into the conversation of cyanobacteria. But there's one other thing he mentioned, is that he also worked with SETI, which is the search for extraterrestrial intelligence.
Ooh.
Did you see her perk up about that?
I did. I did
you
see
see
her
that?
perk up. I'll wait till you hear her in the interview. She gets so excited. I don't think she was like a little bunny rabbit in her seat.
Oh my God.
Oh, yes. Carl
Your
Sagan,
body
Carl
language
Sagan.
says it all. Oh my God.
HelioBioSys actually harvests and purifies ingredients from marine cyanobacteria. And what I'm excited to find out more about is how they're creating clean and natural ingredients, but also products that are actually environmentally safe. I think that's something that's really important to all of us now.
Well, we're just excited to have the opportunity to share this. It's amazing what they're doing and how far we've gone. I mean, pond scum. I mean,
Yeah.
Well, the nice part about it is science discovering nature's secrets, understanding that science is able to see what the earth has to offer, and we're able to break it down and see all the benefits. I've been waiting for this for a very long time, like a little child looking in a candy store. I'm very excited to hear today and looking forward to this podcast.
we're actually talking to him about the funding too. They've spent a lot of time trying to get funding. So there's a lot of support for what they're doing and the future of what they could offer in the cosmetic industry.
Yeah, and I know that Lyra Clinical definitely believes in what they're doing for the future. So really excited to get more information with them because we're going to be diving deep into microbiology. It is truly fascinating and thrilling to see a groundbreaking technology and how it can really make a big impact on skincare, but also the world. And we'll learn more from Rocco and David right after this word from Lyra Clinical.
Lyra Clinical takes today's skincare to the next level. Using cutting-edge technology and the best high-quality ingredients, Lyra gives you brighter, healthier, younger-looking skin. With award-winning products, advanced education, and innovative skincare philosophies, Lyra Clinical is redefining aesthetics and offering superior products and treatments that produce remarkable results. It's beauty from the inside out. Be bright, be beautiful, Lyra Clinical.
When asked where do you want to work when you grow up, one place comes up more than any other. NASA always seemed like that dream job when you were a kid. And today we're talking to two scientists who made that dream come true and discovered an incredible technology here on Earth that is truly out of this world. Let's welcome in co-founders of HelioBioSys, Dr. Rocco Mancinelli and Dr. David Smernoff. Thank you both so much for being here today. I mean, your scientific backgrounds are incredibly impressive. Let's get to know you, though, and your experiences. How did you get started, Rocco, in the field of science and at NASA Ames Research Center?
I always was interested in science. I was always interested in hiking around and going in the backcountry. So I thought, how can I bring the two together? One way in which to bring it together is through ecology, field ecology, and specifically I was interested in microbiology, so I became a microbial ecologist. That allowed me to learn about microbiology, allowed me to learn about the biosphere, allowed me to travel all over the place. And all over the place, I mean, I've studied the microbes that live in the bottoms of the frozen over lakes of Antarctica, that live in salt ponds in San Francisco, in Mexico, in South America. I studied the microbes that live in various different kinds of lakes in the Andes, plus other microbes that live in the soil in the Andes, in the Rocky Mountains, in the Sierras. I've also worked at Yellowstone National Park, Lassen Volcanic National Park, looking at organisms and understanding organisms that live in acid hot springs, boiling water that's actually pH 2, and alkaline hot springs. In other words, boiling water that's pH 10 or more. The whole thing of my research activity when I was actively doing basic research is to try to understand the limits of life in a planetary context. And that actually is how I really worked when I worked with NASA Ames Research Center and had my lab through grants and through cooperative agreements to do all of these studies, because one of the aims of the NASA program is to understand the origin and evolution of life and how it may be off Earth as well. And we're talking about off Earth, we're talking about environments in which we really don't understand. So to get some concept of what are the limits of life, you look at the limits of life here on Earth. And that's how I got started in the whole idea of working at NASA, looking at the limits of life, understanding community structure. And community structure really is the key to what we've put together and one of the things that make us unique at HelioBioSys.
So what is HelioBioSys?
Well, Rocco and I got together and we wanted to do something to help our children's future. And we wanted to use cyanobacteria because we knew what a powerful organism they are and what they've changed the whole planetary landscape of Earth. And so we wanted to get into biofuels. And we thought, well, for the name, so helio is for the sun. And then biology is for the organisms we're using, and then systems. So that's where the HelioBioSys came from. It's like, so we're really big believers in using what nature's already done. Evolution has spent, billions of years perfecting molecules. We don't need to invent new molecules. We just need to use what nature's already designed.
We're working on purifying ingredients from a community of cyanobacteria, and these ingredients are really something I think that will put the cosmetic industry forward a lot. One of them is a UV-absorbing compound. Another one is an anti-inflammatory and antioxidant compound. And the other one is an emollient and a very good moisturizer. Those are our three key ingredients. Those are what we're working on now. We're working on purifying them. We're working on figuring out how much we can make in a little bit of a time and how much we can supply the cosmetic industry. We have put together what you could call a synthetic community, but it's made out of all natural organisms. By synthetic, I mean we just didn't go out there into the ocean or into the soil and grab it and say, okay, here's our community. What we did was we said, okay, we want these traits in these organisms. And we want these organisms to be very efficient. So what's the most efficient thing you can think of is photosynthesis. We want to not have them eat sugar. We want to have it photosynthetic. So what grows quickly? Cyanobacteria grow fairly quickly. Among the cyanobacteria, I chose some organisms that grew quickly. Then I had to figure out, do these organisms grow well together or not? And then a key thing here that we have that most other people don't is that we don't fertilize, because among the organisms that we have put together is a nitrogen fixer. Organisms like you and I and just about everything out there cannot take nitrogen out of the atmosphere and use it, even though we're bathed in nitrogen. But it is a critical element. Without it, you wouldn't have DNA, RNA, proteins, nothing. So I said we got to have a nitrogen fixer, and so what I did is I took like one from column A, one from column B, one from column C, put them all together, and see who worked together. Some of them did, and some of them didn't. And as it turns out, we have a very stable community that produces those ingredients and metabolites that we want. And we started out in the whole business of biofuels and biomaterials. From there, we realized that what our community produced could be better used and sustainably used in the cosmetic industry.
What exactly is cyanobacteria?
So cyanobacteria are photosynthetic bacteria, and most people think of them as algae, and it's really functionally the same thing as algae. And so these photosynthetic organisms have been around on the early Earth since 3 billion years ago. And one of the things that they had to deal with on the early Earth was UV radiation. And so they developed these compounds, these mycosporin-like amino acids, which is just a small molecule that absorbs the UV radiation and gives off that radiation as heat. Nature designed this molecule to protect cyanobacteria on the early Earth. And then cyanobacteria actually put oxygen in the atmosphere and enabled higher plants and insects and birds and humans all to survive and to have an oxygenic atmosphere. So they're organisms that are very prolific, they're robust, and they make these very interesting compounds that our job now is to take the best of what nature has to offer and be able to purify it and get it into the products that protect people's skin, protect them from melanoma, skin cancer, and are actually nice to use.
How does it protect the skin?
So these compounds protect the skin by protecting you from UV damage, just like any other common sunscreen ingredient. But instead of being derived from fossil fuels, they're derived from nature. So this is what nature designed to protect organisms. And now what we want to do is be able to protect our skin with that. They make polysaccharides, which are emollients, and that they can imitate hyaluronic acid. They also make a pigment called phycocyanin, which is an anti-inflammatory, antioxidant, so it protects your skin from pollution damage, from blue light, things like that. So it scavenges those free radicals that we're all concerned about in skin aging.
Wow, even blue light, so HEV, high energy visible light also.
Yeah.
Wow.
Any of those reactive compounds, those, reactive oxygen species and things like that are damaging your skin, these antioxidants then will scavenge those and protect your skin.
David, how did you get started in this?
To be honest, I never thought I would end up in cosmetics. When I was young, you were right, Anna, I wanted to be an astronaut.
Wow.
So when I moved to the Bay Area, I had a cold call interview with a guy at NASA Ames Research Center, and he allowed me to come there and volunteer initially. And so I worked there for a few years as a volunteer, and then I got on a contract, and I worked with them for many years. And we were working on advanced life support. So we were trying to use organisms to be able to support astronauts as they're living on Mars or the moon or long-duration space missions. And so we used algae and higher plants to be able to recycle your oxygen, absorb the carbon dioxide, so to make these biologically based life support systems. And my astronaut application was partially filled out when, unfortunately, the Challenger blew up. And so I kind of gave it second thoughts. Decided maybe I'll keep my feet on the ground. I always want to see the Earth from space, but I'll have to be satisfied with the photograph at this point in my life. So that's what got me started. Rocco and I worked together for a number of years, and then he said, hey, let's do something in biofuels. We're both concerned about our kids' futures, and what do we do about sustainability? And we went down the biofuel path. Didn't work out so great because it's a tough industry to get into. There's huge volumes. And someone suggested cosmetics. And as a guy who uses, soap and shampoo primarily, I relied on the experience of people like, Francine and Metaxia, who, introduced us to what could be possible in terms of cosmetics. And so I've gotten more and more excited about it because I know people who've had melanoma and have survived it. I know people who have not survived melanoma. So it's meaningful to me to be able to do something that, protects people and uses our background in science to be able to translate that into something that's a consumer-friendly product.
Rocco, you're also an astrobiologist, correct?
I am a card-carrying astrobiologist.
Right, so what is an astrobiologist? What do you do?
Well, astrobiology, really, there are three fundamental questions to astrobiology. And those three fundamental questions, I think, reflect the philosophy of what humans have thought about for millennia. And that is, where do we come from? That's the origin of life. Where are we going? That is the future of life on Earth here and beyond. And are we alone? In other words, is there a life that exists elsewhere in the universe other than here on Earth? So those are the three key questions of astrobiology. And so it is truly an interdisciplinary subject matter that to try to answer those questions really in any detail at all requires coming together of people like me, microbiologists, microecologists, astrophysicists, astronomers, biogeochemists. It takes a whole community of different disciplines to work together to try to answer these fundamental questions of where did we come from, where are we going, and are we alone?
You also worked at SETI? I'm
Yes.
a little interested in that.
Actually, what I did is as I said, I worked at NASA Ames Research Center, and but I worked through a cooperative agreement through the SETI Institute, and I worked for them for a number of years. Yes, I had nothing to do with the search for extraterrestrial intelligence.
Oh, too bad. I was going to ask.
No, nothing to do with that. I mean, I'm a microbiologist, so even though I worked at the part of the SETI Institute is to understand the origin and evolution of life. And they have developed what is now called the Sagan Center for doing that, named after Carl Sagan.
I absolutely love reading about Carl Sagan.
David, how did you two meet? David and Rocco, what is that relationship? You guys are just the yin and the yang. You guys are so connected.
Well, we first met at NASA Ames.
Right.
I was working on different projects than Rocco. Rocco was a postdoc, and we were sort of on the same floor together, and maybe shared some lab space and things like that. And then I did my postdoc in France, and Rocco was in Germany for a meeting. And he said, I just got a new grant approved, and we're going to build a microbial bioreactor, and will you come work for me?
Wow.
So then we spent, a number of years working together doing that. And then I took some time off to be a stay-at-home parent. And Rocco called me back in and said, let's do something with the bioreactor and with cyanobacteria to make a better future for our children. And so that's kind of how we started off on HelioBioSys.
Well, it's very nice to see
Serendipity.
where skincare is going.
Yes.
Skincare is a lot more science-based, and we're able to see that we're able to change it at the cellular level.
Yes.
So that's great.
Yes.
So HelioBioSys is focusing on developing clean, natural, sustainable products along with environmentally safe and non-toxic cosmetics. But at what point did you realize that this technology could revolutionize skincare?
Well, the thing that will really revolutionize skincare is the mycosporin-like amino acids, because that is really where the demand is. It's for a really safe and non-toxic sunscreen. That is where the demand, that I think is where we'd make our biggest actual influence on the market. When we can bring the mycosporin-like amino acids at a commercial scale into sunscreens, that is going to change the whole industry. Then we don't have to rely on fossil fuels for chemical ingredients. Then we don't have to rely on zinc oxide and titanium dioxide, which actually have to be mined. Usually they come out of a lot of strip mines. So we don't have to do any of that. This is something that occurs naturally, and that, I think, is going to be our biggest impact in the world of cosmetics.
I love how you initially came in to make a difference in the world with biofuel. Now you're making a difference by looking at ways to protect people from melanoma and skin conditions, but you're also working to help our world by developing a more sustainable product.
And because sustainability is so important to us in terms of the packaging and to the other ingredients that go into it, we want to pay careful attention to all that. So we make sure that we have the most sustainable products that really cause the least environmental footprint that we can.
That's great for the future. So we're actually using nature's protection as our protection. And when you're explaining all the ingredients, there's so much involved. And I know, Rocco, you brought those 3 ingredients. Can you further explain those 3 ingredients that come from cyanobacteria?
Yeah, we'll start with the first one that we started working with, and that is the extracellular polysaccharide. Extracellular means that it is something that the organisms make, and they put it outside the cell. That's the extracellular part. Polysaccharide just means sugar. Poly means many, saccharides mean sugar. So what we have here is we have many sugars all put together. And when you put them all together, they will form what's called a biofilm. But it just so happens that this biofilm, if you separate it from the organisms, has a lot of its own types of characteristics. Those characteristics include being an emollient and being a good moisturizer. You might ask, well, why would an emollient and a moisturizer come up from a cyanobacteria? Well, I said they also are key in forming biofilms. So these cyanobacteria, they live out there in nature. And we're actually trying to mimic nature. So what we've done, this is in our growth. So what we've done is we have taken these polysaccharides, and the organism, that the organisms actually use them to protect themselves from drying out. The organisms that we use tend to be marine. So that means that they have to withstand a lot of periods of desiccation and re-wetting. And so these polysaccharides, they naturally help the organisms go through desiccation resistance. In other words, they protect them from drying out. So if you think about it that way, if you're protecting an organism from drying out, it's going to protect your skin from drying out as well, usually. The other ingredient is phycocyanin. Phycocyanin has been out there for a while. If you look at it, it's blue. It's one of the natural or few natural blue colors that are out there. So does the organism care that it's blue? No. The organism cares because it serves several functions for it. One, it is what's called an extra or accessory pigment for photosynthesis. These organisms photosynthesize. So in addition to that, they serve another function. They're anti-inflammatory, antioxidant. That didn't happen by coincidence. That happened through the whole process of natural selection and evolution. So the organisms use it not only for photosynthesis, they use it to protect themselves from radicals that form in various different ways. One of the ways happens to be if there's any UV radiation that gets through, what does that UV radiation do? It delivers energy to the cell, and it delivers so much energy to the cell that it starts to break things apart. When you break molecules apart, rather DNA, RNA, or even other sugar molecules, you form radicals. Those do bad things. They will destroy the cell. So this phycocyanin also helps quench those or get rid of those radicals. The third one is mycosporin-like amino acids.
Say that one more time.
MAA.
Say that one more time.
Mycosporin-like amino acids.
I might practice that.
Okay.
I like the way he shortens it.
Yes.
up.
They got their name myco actually because they were first discovered in fungi. Things like mushrooms. That's where the myco comes from.
Oh.
But then people realized that they actually are produced by a lot of organisms. And so one of the organisms that produces it happens to be cyanobacteria, and in particular the cyanobacteria that we use in our community. Now, these mycosporin-like amino acids are so versatile in the living world simply because they're so efficient at absorbing UV radiation. UV radiation is extraordinarily damaging to living cells. UV radiation, right now on the Earth, we get UVA and UVB. UVA is longer wavelength, so it doesn't necessarily deliver that much energy. However, we are not protected very much from the sun's UVA radiation. The other radiation that gets through, and unfortunately only a little bit now, is UVB. UVB is a lot more energetic. That means when it hits a cell, it delivers a lot of energy. And usually that energy is really trying to destroy the cell. It breaks apart RNA, DNA, it does a lot of damage. That damage can cause the cell to, if it isn't killed right off, can cause such damage to the cell, and you can get disease from it, such as melanoma and carcinoma. So you really have to protect yourself from UV radiations, as do all living cells. So there's this natural mycosporin-like amino acid that actually is nature's UV-absorbing compound. And so far, every test that's been done shows that it is safe, it is non-toxic, it is being produced in the world's oceans, it is being produced in the world's soil, it is being produced in the food you eat. So it's out there, and it's abundant. And we've keyed in on this because it is so effective as a UV absorber. And we're not the only ones that have actually keyed in on this. This is something that within the industry is known, and it's well known. The thing has been, or I should say the problem has been, how can we get these compounds out of the cell? And if we can get them out of the cell, how can we actually purify them? And to date, nobody's figured out how to actually purify them in large enough quantities to be used in the industry, in the cosmetic and sunscreen industry, so that they can be affordable. All of the purification processes and isolation processes are really quite expensive, and they're usually quite small scale and done in a lab. But to do it at the thousands and thousands of liters is a whole new concept, and that is what we're doing today.
I was just going to say absorption. You were talking about the chemical sunscreens usually absorb the rays.
Right.
So this is now another way of absorbing that's not chemical. It's more natural.
Well, yes and no. The yes means they absorb just like other chemicals out there, like avobenzone is a classic one that's in lots of sunscreens. The difference is that a lot of those synthetically produced or fossil fuel derived types of sunscreens and of UV absorbers are not always that healthy for you in your body, because your body absorbs these things, and it's not always healthy for the environment. It can cause environmental damage. The mycosporin-like amino acids, at least to every test that everybody's shown so far, are not. And I think one of the biggest tests is they're made in the environment, and we already eat them as part of the food that we eat, like mushrooms. You eat a mushroom, you're eating mycosporin-like amino acids.
Clean beauty is what we're looking for. We are looking for more a clean environment, and this is the future of SPF and skincare.
What has been a challenge when claiming this as clean beauty? Because if you look up the word cyanobacteria, one of the words that comes up is toxic or toxins. How do you refute that?
First of all, there's a large quantity of cyanobacteria. There's many different genus and many different species, and only a few of them produce those toxins and cause those harmful algal blooms. So none of the species that we use are ones that produce those kind of toxins. And the other important thing I think to keep in mind is that we're taking the molecules out of the cyanobacteria. So we're not asking you to put cyanobacteria on your face and rub it on your skin. We're actually taking the best part of those molecules that they make out of the cyanobacteria and putting those into the products. So it is very clean beauty. It's a very sustainable process from the cultivation and the purification that we're doing. And those harmful algal blooms, I think it's really a problem, and they can be, people are looking at how to solve those problems, but these are completely different species.
So one analogy might be something like penicillin.
I think that would be a pretty good analogy because, you don't want to eat mold on your bread, right? But penicillin comes from mold. But what they do is the penicillin is purified from those cells, and that is what has saved millions of lives, having penicillin. And what we're trying to do is we're probably not going to save millions of lives with a better sunscreen, but we're going to prevent some skin cancer, we're going to prevent some melanoma, and we're going to give people a product, I think, that is better for them, for their health, better for the environmental health, and people are going to use it more frequently if they like it better, and that's going to also be an advantage, in helping people take care of their skin.
It works more like a chemical sunscreen versus a mineral, which reflects off the rays.
That's absolutely correct.
You talked also about how it's kind of like it's blue in color when it comes out, right?
Not the mycosporin-like amino acids. The mycosporin-like amino acids are colorless. The blue is the phycocyanin.
Gotcha.
So they're colorless because they do not absorb, nor do they reflect any light in what we can say in the visible region, which is all the light that we can sense with our eyes. So they do all their work in the UV region. To us, they appear absolutely colorless.
So what other products can you potentially use with cyanobacteria?
Well, probably the most famous cyanobacteria out there that people have used for a variety of things is spirulina. Spirulina is it's a different genus, and it's called spirulina because if you actually look at it, it's filamentous, which means it grows in a filament, and it's like a corkscrew. It's spiral. So if you look at it, it looks under the microscope, it looks like this green corkscrew. And it too is used for the production of phycocyanin. Phycocyanin is not something that we discovered. Phycocyanin has been out on the market for quite a while now, and people use it as a dietary supplement. So it's out there as a nutraceutical. Most recently, I think people are looking at phycocyanin as a natural blue colorant that's basically going to be non-toxic, safe for the environment, and safe to use. It's been out there, and we get it sort of just by chance because the organisms that we use make it, and they make a lot of it. Our attitude is, it's good stuff, so let's use it, and let's put it in cosmetics because, like I said before, it is a great anti-inflammatory and antioxidant.
It's a very powerful antioxidant, anti-inflammatory, and so the concentrations in any cosmetic process would be very low, and so the blue color would not come through, I don't believe, in any kind of formulation that we would want to put together.
And skincare usually comes from certain things that we eat and benefit us. Chlorophyll, and if you remember growing up,
Yeah, I
your
remember the
mother
story.
would put chlorophyll in your grape juice because I did believe in chlorophyll. So yes, we're on the same page with this. It is very good for you. So whatever is good for you internally is also good for your skin.
Yeah, it's good from the inside out. Now, sustainability is something we've noticed is really important to you. Eco-mimicry is something that you talk about and is an important part of HelioBioSys. But what does that mean exactly? Can you talk about that process?
Eco-mimicry, basically is using nature and using what nature has developed and trying to imitate that in commercial products or in how we manage the environment. And so, like Rocco mentioned earlier, we put together a family of cyanobacteria that grow better together, like your family, right? Works better together than independently. And not only they grow better together, but we're using nature's things. We're using the sun, we're using seawater, so we don't have to fertilize, as Rocco mentioned. So it's a very sustainable process. We're relying on what nature already does, what nature has already perfected through evolution to be able to make these compounds. And then our job as scientists and now as people working in trying to commercialize this business is to be able to economically purify those compounds out and using the least amount of energy, the least amount of water. And then in terms of the packaging and in terms of, all of those other aspects of getting a consumer product into the consumer's hand, we want to pay careful attention to all of that. And I know that in the clean beauty industry, that has become very important and rightfully so. And so because we started in biofuels, we started trying to do something to protect the environment. We're going to absolutely continue that as we get these products into the market.
We're strong believers in following nature, following nature's guide, because usually that's the best way to get the end result.
It's funny because the aesthetic market now is talking about the microbiome. We weren't talking like that 10, 15 years ago.
No.
So there's a shift in acknowledging things about our nature and the benefits. I think it's really important. That's why these podcasts are important, because we need to understand. We need to respect the resources we have and understand them instead of trying to come up with alternatives. We have the power in this universe.
Well, you brought up microbiome, and microbiomes, although we didn't fully appreciate them several years ago, they are extraordinarily important. We have a microbiome on the skin. We have a microbiome in the gut. And I think if you take too many antibiotics or too heavy antibiotics, speaking of your skin, you will notice that in certain areas of your skin, you will start to develop, or in your mouth, you will start to develop a fungal infection. And if you develop that fungal infection, it is because the natural microorganisms that inhabit your skin and your mouth have been killed by the antibiotic. So it allows the opportunistic pathogens of fungi to start growing. So it's called, if you get it in your mouth, it's called thrush.
Right.
You are protected from that from your normal microbiome. And in your gut, you know what happens if that microbiome change, if the balance of the microorganisms that live in your gut changes, you get sick. One of them is the classic Clostridium difficile. If it starts to take over, it takes over, and it outgrows the natural microbiome in your gut, and you get pretty sick.
Wow.
So
Balance
you've got to have a balance.
It's very true.
California is known for the technology, and you guys are just presenting something that is so futuristic. But now we could use this technology and we could get something really going as far as a product in cosmetics.
And we've known you for a few years, and how much you've had advanced in the few years that we know you.
How did you all meet, by the way?
Well, we got introduced through the U.S. Commercialization Service, I believe.
Yes, we did.
And there, Rocco and I had been, out working our DOE grants, and we met a woman.
Cindy Ma.
Cindy Ma, that's right.
Yes.
And Cindy said, you have to talk to Metaxia and Francine because they're doing great stuff with clean beauty and they're science-based. And so as scientists, we thought that we came up, we met, we had a great conversation. You've supported our grant applications in the past, and that's enabled us to help us get, the current grants that we have now from the National Science Foundation. And like I said earlier, you've taught me a lot about the cosmetic industry because I started from zero. And so that's been really helpful to know and understand how this business works and evolves, and nice to see your growth over the years that we've known you as well.
Well, thank you. We're so excited about moving forward together also with all this exciting new developments, SPF products, skincare products, antioxidants, anti-inflammatories. We are constantly looking for what's new. I'm also very excited to find ingredients that are naturally derived.
Now the future. You have both done such incredible work.
They're not going anywhere. We're going to work as a team. We're going to develop some of the best products.
Yes, we are.
Because I have to tell you, it's all about the team, and you guys bring so much information, so much knowledge to us that we definitely want to work as a team on some really good products. So we are definitely, this is just the beginning for us.
Great.
And we want to thank you so much for being here, and we will continue to see what you are coming up with so we can work together.
We're looking forward to getting those products out in the market with you.
Absolutely.
And I love all the experiences that you've had that brought to you where you are today. All our life experiences make such an impact on the decisions that we make in life and how we affect the world around us. And I think that you two are doing some incredible, incredible work and making a positive impact on our world.
Yes, you are. And we see all the new items that you're bringing forth in this industry, and we're very excited to see it go forward.
Thank
We
you.
appreciate your support.
We do.
Well, thank you so much. We appreciate both of you for joining us today. Co-founders of HelioBioSys, Rocco Mancinelli and David Smernoff, thank you so much for joining us on a Skin Depth Convo.
Thank
Our
you.
pleasure. Thank you.
A big thank you to Dr. Mancinelli and Dr. Smernoff for joining us today. Wow, that's the one-word answer I have to the incredible work they're doing with cyanobacteria. Not only are their backgrounds and life experiences impressive, but their initial motivation to take care of the earth and make the world a better place is truly motivating.
I really like to thank David and Rocco for being with us today. It is so very moving to see where they're going with this research. They have so much to offer, especially in the SPF arena, and we're looking forward to working with them in the future.
I really want to thank you for giving us the opportunity to be part of this research. We feel definitely committed to support you in the future with your cosmetic research, and we want to be part of it. We look forward to continue this relationship and grow with you and come up with these incredible products in the future.
That's right. And we're looking forward to continue our conversations and all the new innovative breakthroughs that you're going to be bringing into this industry.
And to think it all started because of research on biofuel.
Yeah.
That's really how it started. And then all of a sudden seeing how initially trying to make the world a better place, saving the environment, and then coming up with a potential now SPF product that will not only help people with skin cancer and helping people, save lives that way, but also, again, helping the environment by making a clean product.
And a natural SPF is something to look forward to.
It is. And exciting to see what products they'll develop with this technology down the road, because there's definitely a lot to come from this. And it was a privilege to have them join us in studio. But before we go, I do have a quote I wanted to share from Fran's favorite, Carl Sagan.
Oh, yeah.
He said, "Imagination will often carry us to worlds that never were, but without it, we go nowhere."
That is so cool. And it's so fitting for you, Fran.
It really
That's
is.
right, because knowledge is power, and they're bringing all this knowledge to us, and we're looking forward to all the innovation moving forward.
Well, imagination does drive innovation. And speaking of innovative products, do we have a product of the day that you'd like to showcase?
Well, our Elio drops. Our Elio drops are amazing. It's funny how it came together very scheduled in a way that was just meant to be. I mean, Lyra has its own direction. It's guiding us. Our Elio and Helio, isn't that funny?
Yeah,
It's just-
Helio.
Yeah,
We got the HelioBioSys, and
Yes.
today we're talking about Elio
Helios.
drops.
Isn't that cool? It means
Well, they
sun.
both mean sun.
Yeah.
And what's nice to be able to offer SPF products that are waterless and no preservatives.
Right.
That is really clean beauty.
It truly is. It truly is. And you can find out more about the Elio drops by going to lyraclinical.com. And if you have any questions for Fran and Metaxia, you can email them at skindepthconvo@lyraclinical.com. That's skindepthconvo@lyraclinical.com. And remember, subscribe and rate the podcast on Apple Podcasts and any of your other favorite directories. But that will do it for us today. For all of us at A Skin Depth Convo, I'm Anna Kagarakis, and we will talk soon.